All right, let's compute this integral. What I want to point out first is that substitution is primarily used just to see the chain rule backwards, and this one can be done informally, so I'm going to show that first. So I have 1 over some function of x, and the derivative of that function of x is just -3. Well, that looks a lot like what I would get if I differentiated a natural log of this function down here. I would get 1 over that multiplied by its derivative. So this is where you want to get to in the long run. With an integral like this, you don't have to do a formal substitution. What I'm going to do is pull the 2 out in front. I'm just going to pop a -3 in the numerator, because that's the derivative of this function of x down here. And of course, you can't just go around putting -3's in the numerator whenever you want. You have to compensate for that. If I multiply by -3 in here, I better divide by it out in front. And so I get a -2/3. And then the integral of this piece is just the natural log of 5 minus 3x plus c. And then to really get a good intuition for why this is working, you can check by differentiating that expression that we just wrote down. D dx, -2/3 natural log 5 minus 3x. And I get -2/3. Differentiate the natural log with respect to its argument, and you just get 1 over its argument. And then the chain rule says you better multiply by the derivative of that argument. And I end up with what I started with, 2 over 5 minus 3x. So it works. So we're really just mostly trying to do chain rule backwards. There are some cases where explicit substitutions are really valuable. It's just that this is one that I would hope you could skip and just see the chain rule backwards. So let's look at this the formal way. I could just give a simple name to this function of x down here to clean things up. We normally use a u for that. Let u equal 5 minus 3x. Then I want to find out what the differential du would look like. And that's -3. It's the derivative of this with respect to x multiplied by dx. And then I can transform my integral. So I have an integral of 2 over 5 minus 3x dx. And so one way to handle this is to force the -3 to happen in front of the dx so that you can see a du there. And that's basically the same idea as what I did on this informal solution. I think I'll just show a little different tactic here. I could replace dx with du over -3. So I'm going to do it that way. And I end up with the integral of 2. Well, dx is just du over -3. So here's a du and a -3 in the denominator. And then 5 minus 3x is just u. And so I get -2/3 out in front. Integral of du over u. And that's just -2/3 natural log of u. And I'm not done until I re-express this in terms of the original variable, which was x. So I have to plug that in. And then I'll be careful to put my plus c on there. Oops. U was 5 minus 3x. All right, and it checks out that we get the same answer, informally or formally. Again, it's to your benefit in the long run if you try to take this informal approach whenever it's possible, when it's simply a matter of the chain rule backwards. And you're going to be a lot more efficient and accurate that way, because I feel like when we get into too much formal symbolism, you can start to get lost in there, and it's a lot easier to make mistakes.